Hello and welcome to the Pythagorean Identities Day 2 video. In this video, we're not going to be learning any new identities. We already have all the identities that we need for Pythagorean identities. We're just going to go through and practice 5 problems. So let's get started. The first problem we have is sine of theta over cosine of theta plus cosine of theta over sine of theta is equal to cosecant of theta over cosine of theta. So remember, this is my statement. I have to pick one side of my statement or hypothesis and simplify it down to the other side. I can't move things along the equal side. It's always going to be easier to take the more complicated side and simplify it down than to take this kind of nicer looking side and expand it out. So we're going to take that sine of theta over cosine of theta plus cosine of theta over sine of theta, the more complicated side, and see what we can do with that. First thing I look for is any Pythagorean identities. So if there's something with a squared and 1, it's probably a Pythagorean identity, but I don't see that here. Next is to change everything to sine or cosine, but it's already in sine or cosine. So my last strategy is algebra. Use all the algebra skills that you have. So I take a look at this and I go, okay, I got some fractions. I need common denominators. So I'm going to multiply this left fraction by sine of theta, top and bottom, and the right fraction by cosine of theta, top and bottom, giving me sine squared theta, or sometimes sine, over cosine of theta, sine of theta, plus cosine squared theta over cosine of theta, sine of theta. Now that I have common denominators, I can add these together. Adding my numerator together. Keeping my denominator the same. And now I look at this numerator, and I know I said earlier that if it's squared and a 1, it's probably a Pythagorean identity, but this is another one as well. Sine squared plus cosine squared. You should have learned this in the last video, but I also put up kind of just a page of all of the Pythagorean identities and reciprocal identities and quotient identities on this page, this Canvas page. So take a look at that. But this is our first Pythagorean identity, leaving us with 1 in our numerator, which is kind of nice. So we have 1 over cosine of theta times sine of theta. Now I take a look at this and I'm a little stuck. And whenever you get a little stuck, you can go back to your original problem, which has the answer. So cosecant of theta over cosine of theta. Well, we already have cosine in our denominator, so let's separate this out. So we have 1 over cosine of theta times 1 over sine of theta. Well, that cosine is supposed to be in the denominator, so I know that's correct. We also know that 1 over sine of theta, 1 over sine of theta is cosecant of theta. So when I multiply these together, I get cosecant of theta over cosine of theta, which is exactly what we wanted. So we've used our algebra skills, Pythagorean identities, as well as reciprocal identities to go through and prove and say, therefore, my conclusion statement, sine of theta over cosine of theta plus cosine of theta over sine of theta is equal to cosecant of theta over cosine of theta. And that's problem 1. Let's try another. So problem number 2 is going to be cosecant of theta over cosine of theta minus cosine of theta over sine of theta is equal to tangent of theta. I'm doing lots of these types of problems because I feel like we still need work on our fraction skills, so I want to make sure that we practice that as much as we can. So again, I'm going to pick the more complicated side. That's going to be cosecant of theta over cosine of theta minus cosine of theta over sine of theta. So there's a couple different ways to approach this. You can start this like what we did with our other problem where we just found common denominators. You can also go through and change this cosecant into something to like sine or cosine. So this is really 1 over sine of theta divided by cosine of theta minus cosine of theta over sine of theta. So I'm going to go through and deal with this kind of left fraction here and try to get that to be nice. Or not nice, just not a triple fraction. So it's really 1 over sine of theta divided by cosine of theta, and you can think of that as cosine over 1, minus cosine of theta over sine of theta. I'm going to leave that alone just for a little bit. Which means we'll have 1 over sine of theta times 1 over cosine of theta minus cosine of theta over sine of theta. I'm going to move this up just a little bit. There we go. So when I multiply these together, we get 1 over sine of theta cosine of theta minus cosine of theta over sine of theta. Okay, so now, in order to subtract our fractions, now we'll do that common denominators piece. And we'll multiply that right fraction by cosine over cosine. And once I do that, I get 1 over sine of theta cosine theta minus cosine squared theta over sine of theta cosine theta. So I can finally subtract these and do 1 minus cosine squared theta over sine of theta times cosine of theta. Now 1 minus cosine squared theta, it's not exactly our first Pythagorean identity, but it's a rearrangement of it. So remember, you can take these and rearrange them. I'll just kind of do some side work. So our first Pythagorean identity is cosine squared theta plus sine squared theta is equal to 1. Now I can rearrange this and subtract cosine squared on both sides and get sine squared theta is equal to 1 minus cosine squared theta. So we can see that 1 minus cosine squared theta is really the same as sine squared theta. So I'm going to replace that and say that in our numerator, instead of 1 minus cosine squared theta, we're going to have sine squared theta over sine of theta times cosine of theta. And when I look at this, I have a sine squared theta in my numerator and sine in my denominator, so I can cancel these out. We'll take out the squared, we'll take out that whole sine, and be left with sine of theta over cosine of theta. And sine of theta over cosine of theta is tangent of theta, which is exactly what we wanted. Yay! So again, mostly algebra skills here. You can do this. But when we end, we have to write our conclusion statement, which in this case is that cosecant of theta over cosine of theta minus cosine of theta over sine of theta is equal to tangent of theta. That's problem number 2. We got 3 more to go. You've got this. Remember, practice makes progress. We're getting better. You're doing great. So let's take a look at problem number 3. So problem number 3 is cosecant of theta minus sine of theta is equal to cotangent of theta times cosine of theta. So here, honestly, they look maybe about the same level of difficulty, but I'm going to start with this right side again. I always just kind of start with the right side out of habit. If you start with the left side, that's not wrong because these things are in fact equal to each other. Just remember, I can't go about like subtract or adding sine of theta to both sides. That's not how this works. I have to pick one side and stick with it. So I'm going to pick my right side of cosecant of theta minus sine of theta. And we're going to start by changing everything into sine or cosine. So that cosecant is 1 over sine of theta, and sine of theta is just sine over theta. But it's really over 1. So in order to combine these fractions, I'm going to multiply it top and bottom by sine of theta. So we end up with 1 over sine of theta, there we go, minus sine squared theta over sine of theta, becoming 1 minus sine squared theta over sine of theta. Now, just like what we did in our previous problems with how we kind of rearranged our first Pythagorean identity, I'm writing it down in blue off to the left. Just like how we rearranged our first one, by subtracting cosine squared on each side. Now we can rearrange by subtracting sine squared on both sides. And we can see that 1 minus sine squared theta is really the same as cosine squared theta, and that comes from the rearrangement of our identities. Pythagorean identities, excuse me. So we can say that cosine squared theta over sine squared theta is our next step. Now, I'm a little stuck, so I look back at my answer over here, and I see that we're supposed to have a cosine, but it's not squared. But we also need a cotangent, which I know deals with a cosine as well. So I'm going to split this cosine squared into cosine of theta times cosine of theta over sine of theta. Now, really keep in mind that sine of theta here is the denominator for both of these technically, but it can also be for one of these, because you can think of that cosine over there as having a denominator of 1. So if we were just multiply those together, we get the same thing. And we know that cosine of theta over sine of theta is cotangent of theta, and that's still being multiplied to a cosine of theta, and that's what we were supposed to get. So remember, if you get stuck, go back and look at what your answer is supposed to be. I really care about the steps. That's what I care about. So let's write our conclusion statement. In that, cosecant of theta minus sine of theta is equal to cotangent of theta times cosine of theta. Whew. I don't know about you, but between all the C's and parentheses, my curves get a little off. Anyway, that was problem 3. 2 more to go. I know I'm going through these kind of fast. Thank you for sticking with me. You're doing a great job. Let's try problem number 4. So problem number 4, we're going to start using some more of our identities as well as more fractions. So we're going to have cosecant squared theta over cotangent squared theta is equal to 1 plus tangent squared theta. So again, both of these look fairly interesting. I think I'm going to start with the right side with a fraction because, you know, fractions take a little bit of work. So if we pick cosecant squared theta over cotangent squared theta, you can do a few different routes here. You can use Pythagorean identities. I'm going to change everything to sine or cosine, but like I said, there are different ways to solve these problems. So if I change everything to sine or cosine, this is going to be 1 over sine squared theta over cosine squared theta over sine squared theta. So here I'm using on top a reciprocal identity, and in my denominator a quotient identity, but the squareds just come along for the ride. So the squareds can apply here. But we have a quadruple fraction, which we are not fans of, so I'm going to write this the long ways. All right, 1 over sine squared theta divided by cosine squared theta over sine squared theta, and then keep the first fraction, change the division sign to a multiplication sign, and flip the second fraction. Or you can think about it as multiplying by the reciprocal. So let's see, if we multiply across here, I can actually already see things that we can cancel out. I'm multiplying by a sine squared in the numerator, dividing by a sine squared in the denominator. So I'm going to cancel those out and leave myself with 1 over cosine squared theta. If I have 1 over cosine squared theta, I can simplify that to to a secant. Sorry, I accidentally muted myself. Anyway, we changed 1 over cosine squared theta to a secant squared theta using our reciprocal identities. But from here, I'm stuck, so I'm going to go back to my answer. There's 1 plus tangent squared theta. And I go, hey, 1 plus tangent squared theta, that's an identity, Pythagorean identity, that's equal to secant squared theta. So I can say that secant squared theta is equal to 1 plus tangent squared theta, and I've done my problem. So we've used all 3 types of our identities that we know so far. We've used some algebra skills. I think this is a really great problem. So let's finish it up with our conclusion statement that cosecant squared theta over cotangent squared theta is equal to 1 plus tangent squared theta. That conclusion statement, I always think about that as like a bragging statement. But remember, we've got one problem left that we're going to do. Thank you for sticking with me. I've been talking fast because I'm trying to do this in under 20 minutes. Let's see if I can make it. Whoop. Okay, problem number 5, last problem we're going to do together is tangent squared theta minus sine squared theta is equal to sine squared theta times tangent squared theta. Oops, extra parenthesis for no reason. Okay, so both of these sides are, fairly not great. So again, I'm just going to pick the right side of tangent squared theta minus sine squared theta. Let's see, they're squared, but they don't show up in an identity together. So I'm going to change everything to sine or cosine. So tangent is sine squared theta over cosine squared theta minus sine squared theta. And I'm going to stick this sine squared theta over 1 so I can have 2 fractions and multiply this right side by cosine squared theta top and bottom. So we end up with sine squared theta over cosine squared theta minus sine squared theta times cosine squared theta over cosine squared theta. Woo! Okay, so now I can subtract these and get sine squared theta minus sine squared theta cosine squared theta over cosine squared theta. So I look at that numerator, and that numerator is kind of a mess. I really want to subtract these sine thetas, but I can't do that because this sine squared theta is being multiplied to this cosine squared theta. So instead, I'm going to factor it out. Just like if I gave you a problem of 2x plus 8, and I said factor out what they have in common. Well, they both have a 2 in common, so I can say this is 2 times x plus 4. If I was to take this 2 and multiply it back in, this is what I would get. So when I take a look here, I see that, hey, my 2 terms have a sine squared in common. So that's what I'm going to factor out. So this is going to be sine squared theta times 1 minus cosine squared theta over cosine squared theta. And we can see that if we were to go backwards and take the sine squared theta and multiply it in here, this is what we would get. But I look at this 1 minus cosine squared theta, and I go, oh, 1 and a squared, it's probably a Pythagorean identity, and we've actually dealt with this one before. This is a rearrangement of our first Pythagorean identity. And we know that 1 minus cosine squared, ooh, sorry, that's a highlighter. It's not what I meant to do. There we go. 1 minus cosine squared is actually sine squared theta. There we go. Over cosine squared theta. And just like what we did in problem number 3, I'm going to say that that cosine squared theta is being multiplied to a 1. So what we really have is sine squared theta times sine squared theta over cosine squared theta, which is tangent squared theta. We did it! Yay! Proud of us. So remember, final conclusion statement where we get to brag that we know and have proved that tangent of theta, squared theta minus sine squared theta is equal to sine squared theta times tangent squared theta. Woo! Did it in 20 minutes. Under 20 minutes. I'm very proud of myself. I have lots and lots of practice problems, so if you want more practice, please let me know. Send me emails, find me during office hours, wait after class. We can practice these together. Feel free to practice these on your own. There's a Go Formative waiting for you. I look forward to seeing you on Thursday.